All right, guys, today we're on lesson 4.4, and we're going to start with task 1, factor polynomials. All right, it says analyze a visual model for polynomial factorization. Factoring a polynomial involves finding factors of less degree that can be multiplied together to produce the polynomial. You have already factored polynomials of degree 2, as in the example below. So last year we factored x squared plus 5x plus 6. These are quadratics, and we did do some factoring. So we would rewrite this is standard form. We would rewrite it in factored form as x plus 2 times x plus 3. When a polynomial of degree 3, you can think of it as the volume of a rectangular prism whose dimensions you need to determine. The dimensions are the factors of the polynomial. All right, a regular prism is subdivided into 4 smaller rectangular prisms as shown. The volumes of the small prisms are given below. Red, I guess we're going to call this red. So R is the red, G is the green, Y is the yellow, and B is the blue. All right, so red, you can see that this is one side, this is the other side, and then the height is the third side. So red is x times x times x. Green is right here. So we know that this side is x because it's the same as this over here. So we know this side is x, and we know this side is x as well. But it says that the green is 2x squared. So if we know the x squared part come from here, then we know that this part has to be 2. Okay? All right, and then the yellow we know that the height has to be x because it is on the others. And we know that this is 2. And so the other side length that we don't know right here would have to be 4, because 4 times 2 is 8, and that's what it says. 8x is the volume there. And volume is always length times width times height for a rectangular prism. And then we've got blue. Blue, we know that this side of this box is the blue and the red share a side, so we know this side is x because it was on the red side. And we know that the height is also x, so that's where the x squared come from. And that means that this also has to be 4, which we already determined from the yellow one over there. So that's how they got these dimensions here. And if you multiply length times width times height, the total volume is shown here. All right, so it says select the correct response from the drop-down menus to answer each question. The volume of the red prism is found by cubing the length of one side. This edge is the height of the large prism, which is the height. What is the height of the large prism? All right, so we already determined that red, the whole volume is x cubed, so it's x times x times x. So the height would be one of those x's. The volume of the green is found by multiplying 2 of its dimensions shared by the red prism and one other dimension. Okay? So the green is shared by a height of x and a length of x, and this would be 2. So what are the dimensions of the green? X by 2. All right, the combined width of the red and green prisms make up the width of the large prism. So the red and the green. All right, so the red and the green make up the width of the large prism. What is the width of the large prism? So it would be x plus 2. All right, so we already determined that this was x, and this had to be 2, and we knew that all of these were x. So that means this width across from here is x plus the 2 here. All right, explain how you knew the dimensions of the green prism. All right. The yellow prism shares 2 dimensions with the green prism. Select the correct response from the drop-down menu to answer each question. What is the third dimension of the yellow prism? All right, if we go back up and look at the yellow prism, that's the one here in the back corner. We know the height is x, and we know this side is 2 because that's 2 for green. So if this says 8x, we know 2x times 4 is 8. So we know that this other side has to be a 4. What is the length of the prism? Okay, so the length is going to be this side here, which is x, and then this is plus 4. All right, it says the volume of a prism is length times width times height. Write an expression for the volume of the large prism. Do not simplify the expression. Select to reveal the expression. All right, so we had x plus 2. We have x plus 4, and the height is just x. So we've got length times width times height. Which of the following represents the simplified expression from part E? All right, so if we multiply these together, x times x is x squared, plus 4x and 2x give me 6x, and then plus 8. And then if we multiply all those by x, it all goes up by 1 power. So that means when you multiply that out, you're going to get x cubed plus 6x squared plus 8x. All right, select the arrows to see how this information connects to our large prism. All right, the product equals the given expression for the total volume. And the factored form is x times x plus 2 times x plus 4. Can you factor any cubic polynomial of the form x cubed plus bx squared plus cx by modeling the polynomial with a rectangular prism and finding the prism's dimensions? All right, so most of the time you should be able to do that. I would think that it's going to be easier if the cubic is factorable. So if it's factorable, meaning the side lengths are going to be integers and not fractions. So you may be able to do it even if it's fractions, but it would be more difficult to do it if it were that. All right, that's all for task 1. We're going to move on to task 2. All right, this is lesson 4.4, task 2. Factor out the greatest common factor first. Not all polynomials can be factored over the integers. That is, they cannot be rewritten using only factors with integer coefficients and constants. When a polynomial is factored, the degree of each factor is less than the degree of the polynomial. Remember, degree is your highest exponent. All right, while the goal is to rewrite the polynomial as a product of linear factors, this is not always possible. A factor of degree 2 or greater that cannot be factored further is an irreducible factor. The first step for factoring a polynomial is to factor out the greatest common factor of the terms, assuming it is not 1. Below are 2 examples of factoring a polynomial over the integers. All right, so again, we've done greatest common factor before, so this should look familiar. All right, so if we're given a higher degree, we're given a cubic polynomial, first, to find the greatest common factor, you see what number goes evenly into all 3 numbers. So 4 can be factored out of 8, 4, and 12. So 4 is the number that's the greatest common factor. And then we have x cubed, x squared, and x. So x can also be factored out of each term. So our greatest common factor here is 4x. And if you factor out 4x, then you are left with 2x squared minus x minus 3. And you can see that factoring is just rewriting this polynomial. So 4x times 2x squared is 8x cubed. 4x times negative x is negative 4x squared. And 4x times negative 3 is negative 12x. So again, factoring is just rewriting that expression. All right, and then they went on to factor 2x squared minus x minus 3 could be factored even further. So 2x minus 3 times x plus 1, if multiplied together, would give you this right here. All right, it says, how do you know that the greatest common factor is 4x? Well, we just looked at each term to see what was the greatest thing we could pull out of each term evenly. Okay, so you want to pull out integers and variables, but like you wouldn't want to pull out fractions and things like that. So that's why we want to find the greatest common factor would be the integers and the variables that could be pulled out evenly from each term. All right, so here's example 2, 3x cubed minus 21x. All right, 3 and 21 both have a common factor of 3, and x cubed and x both have a common factor of x. All right, so I could pull x cubed out of this one, but I can't pull x cubed out of this one. So when you're dealing with variables, again, it's the largest one that comes out completely, just like with the numbers. So 3x would be your greatest common factor. And then 3x times x squared is 3x cubed. 3x times negative 7 is negative 21x. Why can't you factor x squared minus 7 over the integers? But you could factor x squared minus 9. All right, so x squared minus 7 will not factor any further, so that's why they stop. This is completely factored. If we had x squared minus 9, we know that x squared minus 9 is a difference of squares, or at least I hope you know that. Okay, we did look at that last year as well, but this is a good refresher. All right, so if you have a perfect square and a minus, so this is called a difference of squares, exactly what it looks like. In math, you'll find that most names of things come directly from what you see there. So this is a difference of squares. And it says that x squared minus 7 is not a difference of perfect squares, and x squared minus 9 is a difference of perfect squares. So remember, x squared minus 9 can be rewritten as x plus 3 and x minus 3. All right, explain why it is possible to factor x squared minus 7 over real numbers but not over integers. All right, so if you wanted to factor this further, real numbers just means you bring in fractions and other things, but we mostly, when we're talking about factoring, we just stick to integers. So that's what we want to do. All right, if you have any questions, please let me know.